Hey there. Today we're going to be answering the following question. A painter leans a 25-foot ladder against a wall. When the painter lowers the top of the ladder by 9 feet, the bottom of the ladder is 20 feet from the wall. Part A of the question is represent the situation with a diagram, and part B is how far from the wall was the bottom of the ladder originally. Now we can actually answer this question in two ways, so that is what I will be doing. First we'll go through parts A and B with one way, and then parts A and B through the second way. So part A here is, well, let's draw a picture. So originally, so this will be our wall, that'll be the ground, and then a painter leans a 25-foot ladder against the wall. So let's say that's our ladder there. When the painter lowers the top of the ladder by 9 feet, the bottom of the ladder is 20 feet from the wall. Okay, so we'll use a different, let's use red. So let's say that it's lowered by 9 feet. So the black is the original ladder, and the red is after it's been moved. And here, this thing is a drop of 9 feet. Okay, and then, well, the length of the ladder, so let's say the length of the ladder, so well, let's go with the red. Okay. Now let's say, so the red here is 25 feet, and then the black is also 25 feet. Okay, and we're also told that after it's been moved, it's 20 feet, the base is 20 feet from 20 feet from the wall. Okay, so that's going to be our diagram, and the value we want to figure out for part B is how far from the wall was the bottom of the ladder originally, and that is this length here. We want to figure out that x. So the way we can think about it is because this length here is 25 feet, that's the length of the ladder originally, and the length of the ladder hasn't changed here. So this is 25 feet here. If we can figure out the length here, then we can use the Pythagorean theorem to figure out the length here. And since we know this little bit here, if we can figure out this length here, we can add it to the 9 to get that length. So we know this side here and this side here, so we can find this side here. So let's start with that. So using the Pythagorean theorem, let's go with, let's go back. So we're going to use our a squared plus b squared equals c squared. And better idea is, let's do this one in red actually. Keep with the triangle we're working with. Okay, so we're going to use a squared plus b squared equals c squared. And so we want to figure out, we'll call this our a. So that'll be our a. So we want to solve for a. Let's call 20 our b, and this will be our c. So we got a squared plus 20 squared equals 25 squared. We can subtract 20 squared from both sides to get a squared equals 25 squared minus 20 squared. This is equal to 625 minus 400. So this is equal to 225. But we can take the square root of both sides to get that. And that is equal to 15. So this length here is going to be equal to 15. Alrighty. So now back in our original triangle land, I will draw the picture again down here. So we have our ladder of 25 feet. The height is going to be our 9 plus 15, which is equal to 24. And then we want to solve for the base. So here again we have a squared plus b squared equals c squared. We'll call this our A, this will be our b, and this will be our c. So we want to solve for b. So we're going to have 24 squared plus b squared is equal to our c squared, which is 25 squared. So subtracting 24 squared from both sides, we're left with b squared equals 25 squared minus 24 squared. 25 squared is 625. 24 squared is 576 after you do the math. And the difference between that is 49. So b is equal to the square root of 49, which is equal to 7. So originally, the bottom of the ladder was 7 feet away from the wall. So that is one way to do it. That might be the first obvious way to do it. But there is also one other way to do it using algebra. So I'm gonna try to move everything up here. Let's see if we can keep the original questions within sight. Okay, so actually no, we'll be fine. We'll be fine. So let's just move that out of the way. Okay. So now, so using algebra, so we're gonna draw a diagram, and we're gonna have two triangles. So this is gonna be the original position of the ladder, and then we'll just call this the later position after it was moved. Okay, so we'll have two triangles here. So in the first, for both of them, the length of the ladder doesn't change, and we'll call the original height against the wall x, and the original distance away from the wall of the base of the ladder as y. And in the later position, we're told that the ladder was moved down 9 feet. So here, we can call the height x minus 9. And we're also told that the base of the ladder, after it's moved, is 20. So here now we have two situations in which we have two variables, x and y, and we want to solve for y. So for the right triangle, we can use the Pythagorean theorem because this is a right triangle, same with this one. So let's go with that. And we're going to call this our A, that will be our B, and this will be our C. So we'll go with A squared plus B squared equals C squared. Our A is going to be our x minus 9 squared, plus our B squared, which is 20 squared, which is equal to C squared, which is 25 squared. So then we can unpack this a little bit. Let's go x minus 9, x minus 9. And I'll do the multiplication here. So 20 squared is going to be 400. 25 squared is going to be 625. So we have that. So now we can do FOIL on the x minus 9, which will give us x squared minus 18x plus 81. And we can subtract 625 from both sides as well to get minus 225 equal to 0. And then, if you do the math, 81 subtract 225 will give us minus 144. So now we want to factor this thing. So in order to factor this thing, we want to find two numbers, C and D. Let's say two numbers, C and D, which when multiplied together gives 144. But also, when you add them together, they give us negative 18. So the way I think about this, first of all, is for 144, because I know that's 12 squared. So 12 times 12 equals 144. But if I add those two numbers, won't give me 18. The other thing to recognize with this factoring is that it's going to be of this form, but as well, because this sign here is a negative, we are going to have opposite signs in the middle. So when we go back over here, we're going to need to realize that we need to find a negative and a positive number. Okay, but again, so if we have 12 and negative 12, well, you add that together, you get 0, so that doesn't help us. But let's say we multiply one of these 12s by 2 and divide the other one by 2. Okay, so we get 24 times 6 equals 144. Well, if we have negative 24 and we add 6, that'll give us negative 18. So those two values work. Now, so which one to put in? Well, you can play around with it a little bit, but you'll eventually realize that you have to go there. So, and solving for this gives us x equals minus 6 and x equals positive 24. Now we're looking for a length, so the negative 6 does not make any sense whatsoever, but the x equals 24 does. So here, the answer for this will be x equals 24. And if you look in the top left triangle again, we can set our x equal to 24. And now, we again, over here, have another case of the Pythagorean theorem. So we'll call this our a, this our b, and this our c. So I have a squared plus b squared equals c squared. Our a squared will be 24 squared plus b squared is equal to 25 squared. B squared, which y is our b, so we'll just plug that in. We'll have 25 squared minus 24 squared. 25 squared is 625. 24 squared is 576. And the difference there is 49. And so y is equal to square root of 49, which is equal to 7. So that is the second way you can solve this problem. The first way was by a more visual kind of intuition. The second way was through a little bit of algebra. And I guess you could argue that if you can understand the algebraic way to look at this situation, this way might be a little more easier because you set up two Pythagorean equations and then you solve for one variable and plug it into the other one and away you go. In the one above, let's see if I can move up here. Whoops, apparently it went away. So in the second one above there that we did originally, that one was done through more of a visual demonstration. So either way will work, but hopefully one of those will work for you.